So, hello, my name is Mihika.
I'm Cameron.
I'm Matthew.
And today we'll be talking about silver nanoparticles biotoxicity. And biotoxicity refers to when environmental toxins are introduced to living organisms.
So basically, for a little bit of context, what we did in this experiment was we took 3 types of silver, nanoparticles, ions, and powder, and we mixed each of those separately with yeast powder, and then we measured the gas production that was created by each of these mixtures. And basically, the reason why we did this was because the making of CO2, or carbon dioxide, is a result of cellular respiration, which is a process that occurs in healthy cells. So the less CO2 production equals greater silver toxicity.
All right, so starting from the top up there, we can see that there are people just lining up to get into the theater. It's hard to see from far away, but there are different types of tickets. There's the kids who enter for free, and then the adults right there who go in for $5, and then the cocktail lady who goes in for $20. So this basically represents like different mechanisms. In the first concept, where we're just talking about how each size of silver, which means like each like tier of tickets, they all get into the theater, but they just enter a different way with different like standards.
Okay, so during this experiment, we also learned how all forms of silver damage the cell in the same way. So in the image, we can see how the premium person, the adults and the children are all spilling the drink, and they're all damaging the cell, which in this case is the movie theater.
Okay, so another important concept of this experiment was that different sizes of silver can have different effects or levels of toxicity on cells. So the silver nanoparticles had the greatest level of the greatest toxic effect on the yeast cells because they're the smallest. So the yeast cells pertained it to be food and took it in through endocytosis. So as you can see, that relates to the picture because on the bottom you have the small children who are the smallest people here, and they make the biggest mess. And then you have the adults up here who make a slightly smaller mess, and then you have the fancy cocktail lady, whatever, and she makes a small mess. So that kind of relates to the nanoparticles versus the ions versus the powder in the experiment.
Okay, so this guy right here on the side for each one, it's basically like one of those, like, after you leave a movie theater, there's that one guy who's just waiting for everyone to get out so that he can, like, clean up the theater. So on the top, you have the fancy cocktail lady. She didn't spill on much, so he only has, like, 1 paper towel. And then right here, they spilled, like, a bit more, the adults, so he has more paper towels. And right there, all the kids are making a mess, so he has, like, 10 of them, and he's, like, dead, and he's, like, upset. So this basically represents how, in the actual experiment, we measured how the amount of CO2, which shows if the cells are, like, dead or alive. But in here, it's just using the cleanup guy as the metaphor to explain the amount of paper towels show how much of a mess there is to be cleaned up.
Okay, so adding on, we thought that this image captured the experiment very well, and then the metaphor itself helped explain this process. An additional concept that we thought could have been added was the different forms of silver in terms of color and how smaller particles have shorter wavelengths.
Yeah, so one other limitation was the fact that, the kids versus the adults versus the older lady, they're very similar in size in real life, and the nanoparticles, ions, and powders are obviously very different in size, and you can't really represent that in real life because the nanoparticles and stuff are so small. But that was pretty much the only limitation to this that we saw besides the concepts that weren't mentioned. But yeah, so thank you for listening. Is there any questions?
Yeah, in the drawing, wouldn't it be children, student, and adult, potentially? I don't understand the logic of it be a cocktail waitress person at the top. And also, is there any representation between 3, 2, and 1? 3 kids, 2...
If you look at the very top, it's really hard to see from where you're sitting, but the little ticket sign, it says kids are free, and then adults are $5, and then premium is $20. So we kind of figured that the ones in the middle were adults because they were buying adult tickets. So yeah, it would make sense if it was kids, students, adults, but just the way that they drew it, it wasn't like that.
Okay, I have a question. So I just want to make sure that you guys have the size thing correct, because I know in this case it might be a little switched from how it actually is. So which of the 3 is representing the nanoparticles?
The kids.
The kids, because they're the smallest. Yeah.
So, and which in the actual experiment is the smallest?
Nanoparticles.
not the nanoparticles, but
Oh, sorry, the ions.
the ions, right? So, so in this case, even though the kids are doing the most damage, it is kind of flipped from the experiment, right? Because in the experiment, like you said, the ions are the smallest. And for all three of them, what is actually doing the damage?
Oh, what's actually doing the damage is like the toxic nature of the silver.
The silver, which silver, or what silver?
The nanoparticles, because it got into the...
But what are the nanoparticles and the bulk and the ions all, like, what are the bulk and the nanoparticles releasing to do the damage? Do you remember?
The +1 ion.
The ions, right? So it's always ions that are doing the damage, but just in the case of the nanoparticles, it's actually able to release the most ions into the cell because it, as a whole like chunk, gets into the cell, whereas the ions have to go in individually and it's slow, and the bulk releases so few of them, right? So good. Just wanted to make sure that was clear, because I know that with the children being actually smaller than adults, that gets confused, then that could be confusing.
In the picture, it implies that the janitor can clean up the mess afterwards. Do you get a sense that the silver ions effectively killed off the yeast cells completely, or was there an opportunity to perhaps remove the ions that they put in and keep some yeast cells alive?
Well, the question was like, how the janitor like shows like which one like got killed or whatever, like in relating to the experiment. So I mean, with the kids, it shows like it's really hard to see from here, but like the eyes are like X out kind of thing, and like in that situation, I guess it would in the experiment there would be like a little bit of like CO2 created, but like most of them got killed like really fast. But like in the terms of like the other ones, they can still clean up the mess, but it's just more, I guess. It wasn't very like specific.
So then to follow up, in the case of the bulk silver, so it is doing some damage, right?
Yes.
But if you didn't see anything, like some groups actually saw that even with the bulk powder, the ones there actually, the yeast maybe even seemed to do better. So why could that be the case? So what's also happening as yeast cells are being killed? What are the yeast also doing? Or what might they be doing? What do living things do in
Respirate?
general? Sorry?
Respirate?
They respirate, that's one thing. What else does life do?
Multiply?
Multiply, right? So what is the yeast then also doing that could be counteracting the effect of them being killed off?
Reproducing,
within
right?
The time. So even if bulk silver can do some damage, it could be that the yeast is just reproducing at a greater rate, that it kind of, as a whole, counteracts the damage that any sort of individual death of yeast might do to them as a colony.
What do you think the charge represents? Like how they charge different amounts of money? Do you think that has any significance to the silver?
I mean, from what we interpreted, we just thought it was just like the different like kind of like tiers and like the size, like being like financial wise, like free is like the lowest and just higher, but we didn't really think anything else of it.
Well, and if you see the premium entrance, the lady at the top, there's a separate entrance for her, for everyone who has the premium tickets. So that sort of makes more sense in terms of the experiment with the bulk cells.
So kind of going off of that, like so as Rita was saying, like the nanoparticles are the medium-sized things of the three things that you guys tested, right? How could you have changed this picture to more accurately reflect that? Like, if you're saying that the price of the ticket is more due to the size, how can you represent that better, and like the charge on the particle versus the ions better? Because I think it's a little.
You could have, instead of the kids being free, you could have them have a certain like a certain amount of money, just a very small, so that it would sort of make more sense, because right now it's 0, which kind of implies that they just enter without a fee, sort of. So it would make more sense if they had a small charge, like to get in.
Well, okay, so I guess what I'm trying to ask is, like, you were saying that the price of the ticket is kind of trying to show the size of the silver, right? But the free one here is the one that goes in the easiest. But in the
charge on the particles is another thing, right? As we saw from the previous group that showed this experiment, the charge on those ions is something that's preventing them to get in the cell. How could you think that they could show that?
So I guess just having one of the groups like not being able to make it in to the movie theater.
You could have the kids, if they're underage, they would need an adult or something to come into the movie with them because they're too young. Say if it was PG-13 or something like that, and they need an adult to come in with them. So that was a limitation.
All right, thank you guys.